So this is your karate data set with the nodes at the top and nodes to the left and zeros along the diagonal. This is the adjacency matrix. Ones represent the connection between the two people. And this is the data set that you're working with in order to run your algorithms and try to get two clusters which closely match the true values as possible, right? And as you guys have noticed, the results of your graphs have been two off. And I just wanted to mention that Jeffrey Dang made the statement that using this data alone, he feels that 2 is the best that you can get, right? I mean, match all of them except for 2 is the best result that you can get. And I'm thinking, because all of you guys can't break that 2 mark, that might be true, right? And so this is coming from the original paper that was created by Zachary so-and-so, right? And what he did is he ran an algorithm called the Ford-Fulkerson algorithm, which Jeffrey Dang is actually working on, and he's able to get 1, okay, 1 missing. And the way that he's able to get 1 missing is that he doesn't use just this data. He takes this data and turns it into a third dimension. And what I mean by that is that we have these are the different classifications of how a relationship is determined. If 2 people have any one of these guys satisfied, then they get the 1, right? So but what this guy did, Zach did, is he if an individual had a relationship with another individual and satisfied 2 of the relationship categories, then it wasn't a 1 that was placed in the 2D array, it was a 2. Right? If he had 3 of these relationship types satisfied, then he would have a 3, and so on. So you could have a max possible value of 8, and the adjacency matrix that he uses is not really an adjacency matrix, it's more like a weighted matrix, is this one here, right? So this means that node 3 and node 9 had a very strong relationship, right? Because they had 5 of those. They basically did everything together, right? And then node 25 and node 1 did nothing together, so they had a very weak relationship. And then what Zach did is he took this data and he ran an algorithm that Jeffrey's going to go into later, and he was able to get 1 off, right? So the more that you guys are coming up with your results and finding out that there's only 2, you're 2 off, you can't break that 2 mark. I'm thinking that it might be because that data. Jeffrey made the statement earlier that the amount of data that's contained in the adjacency matrix is not fine enough to break that 2 mark, right? And even this one here that has additional information, when you run a clustering algorithm on it, this one is able to get 1 off, right? So I think an interesting question to ask Dr. Hasibi is what algorithm did the PhD student that he was working with use to get 1 off on the Karate Club data set, right? And I'm thinking Jeffrey's right, that it's because that he wasn't working with the adjacency matrix. He was actually working with this matrix here. So we'll find out.